Today I will talk about a new project that is kind of I think that is kind of intermediate level of our Arduino project, because at first we used to do like LED and blah blah blah, which is very much elementary. But today I will discuss something different, that is gyroscope, and additionally something more than that. And what is the use of this?
Ready to uncover the secret sauce that keeps drones flying smoothly? Let's get started. At the heart of every drone's stability lie two unsung heroes, the accelerometer and the gyroscope. First up, the accelerometer. This tiny sensor measures acceleration in three directions: forward and backward, side to side, and up and down. Imagine moving a drone forward. The accelerometer detects this motion and sends real-time data to the drone's control system, adjusting speed and balance. Now, tilt the drone rightward. The accelerometer picks up this shift too, ensuring smooth turns and maneuvers. And when the drone ascends, the accelerometer measures the upward acceleration, helping it maintain a steady climb. Next, let's talk about the gyroscope. This sensor detects angular rotation around three axes: the x-axis, y-axis, and z-axis. Tilting the drone forward or backward, the gyroscope senses this rotation and makes tiny adjustments to keep it level. Tilt it side to side, and the gyroscope is on it, maintaining balance. Spin it clockwise or counterclockwise, and the gyroscope ensures the drone doesn't spiral out of control. Together, the accelerometer and gyroscope work in harmony, providing real-time feedback to the drone's control system. The result? A stable, responsive flight, whether you're capturing stunning aerial footage or racing through an obstacle course.
Okay, for that I am first time using ESP32 before you, and for that you have to come, like I start from the beginning. Come to my project, start new, and I need a ESP32, and then Arduino. Okay, fine. This is my workplace, and okay, let me simulate. Let me connect this, and then we will move to the code. Let's explain what I've done. Before that, I want to uh, be sorry for mention the wrong name of this component. This is gyroscope and accelerometer, and these have various pins. But what that pins I need now, I will explain that. If you have enough interest, you can ask ChatGPT. It can help you to understand each and use of each and every point. Okay, first of all, it is ESP32. Well, we need to connect the power pin VCC. I explained earlier the VCC pins. It will be connected with volt, right? And that's why I have connected it in 5 volt. And then ground, I have explained earlier, ground will be connected to ground. And if you observe, then you will have other ground pin in this column. You can also connect with this as well. And the next thing, that is SCL and SDL. As I have explained, I think time and again in my previous videos, while I was explaining the LCD screen, what is the work function of HCL and what is the function of SDL. So if you are following my videos, I think explaining this the function is like nothing but time waste. So I am connecting SCL with 22 tooth pin, and SDL with 21th pin. And it is very much essential to keep in mind that I have to connect this two pin with this specific pins. Okay. Okay, fine. Let's move on to the code. Okay, fine. This is the code. That is very much a lengthy code, so it is very I think it tough as well to type before you. I have read the code earlier, and I would like to explain this line by line whatever you need to do, and to listen me carefully and understand whatever I am saying. This is Adafruit MPU6050.h. This is the header file to understand the command I want to give with related to this component. If you, whenever you search this component, like I am showing you like gyroscope, see that MPU 6050. So this is the name of this component, and this header file contains the command that I need to do and I can do with this component, and will help the compiler to execute the specific thing that I want. Okay, then Adafruit sensor.h. This is also a header file, and then next thing that is include wire.h. I have explained it earlier what is the use of wire.h. Wire.h is a header file that help me so that I don't need to explain the connections. Okay, like I've said earlier that you have to connect the SDA with 21, SCL with 22, because in this wire.h, in this header file, it is by default written that the HCL will be connected to this pin, and the SDL will be connected to 21th pin. So if you code perfectly and if you have connected perfectly, but you didn't maintain the connection of these two pin, then definitely the code will not work, because by default the demand and your configuration is matching. Okay, this is the what is the use of this wire.h? Because just only explaining or just writing this header file, it helped me that I don't it helps me in this respect that I don't need to the connections line at all. Okay, fine. And this is Adafruit MPU. Actually, this if you are familiar with like C program, then you have written as like if I show you like okay, fine. We may be familiar with C programming. So if I declare a variable like a, so I need to declare what type of variable it is. So I need to say like int a, isn't it? Okay, and then in this case this is having the same thing, the MPU. This is the name of the class, and what type of class is it? This is Adafruit MPU 6050. I think you have got the point. Then it comes void setup and void loop. We know that void setup, we need to mention those setup that have to have for the first time and for the last time. I think in the whole code I have to do this setup for one time only, a single time only, those have to written in the voice setup. Those duty have to execute it time and again in that code repeatedly, that have to be mentioned in the voice loop section. Okay, so what about the writing code indicates here? Serial dot begin 115200. This, I think, I don't need to explain because I have explained it earlier. It says to start the communication. Okay, and in what rate? This number is showing the rate of the communication. Okay, and then using this line, I have started the communication, I have started the work. Okay, and then it comes the if this happens. For look at this MPU. I think you can got the point. MPU means this objects. Okay, actually this is as I have said earlier, like it is similar to the variable and the variable declaration type. So MPU dot begin, that means I want to start initialize the MPU that I have declared earlier. So, and now notice something different, that is not, this sign represents not encoding. Okay, so if this is 0, this is the interpretation of this line. Okay, if there is no this exclamatory sign, only this is written, I think this one is written, that means true, means 1. Okay, if but in this code this is not signed before this, that means 0 or false. Okay, so if it is false, I mean this means if nothing is executed, then serial print in failed to initialize MPU 6050 sensor. That means that if nothing executed, nothing happens, then definitely give me a what means a message that there is an error in the sensor. But if the MPU full stop begin equal to 1, or if you can omit this part as well, this part. Okay, so if this is equal to 1, that means if it is true, then delay for 20 seconds. Okay, and when it will happen, when don't notice that the if and then this is nested while. Okay, so this, the summary is, if nothing happen, nothing initialize, then the compiler will go in this section, and then it will work for 20 seconds for new updates, new data. If nothing happens, then finish, but if happens, then it will go in this loop. Okay, fine. And then the while loop, the while loop again, like ACC, GYRO, TEM, these like one kind of variables. Okay, that I have said earlier, that int a variable, and int there denotes its type. So similarly in this encoding, ACC, GYRO, TYMP as the variable. Okay, where I will put the datas. Okay, fine. And MPU dot event dot get event, that means definitely I am getting the data, whether the drone is rotating with respect to x-axis or not, what is the rate of rotating with respect to x-axis or y-axis or z-axis, or what is the temperature of the surrounding, and is there any acceleration along the x, y, or z-axis. So this data will be stored in ACC and GCC, gyro and temp. This ACC will store the acceleration update along the x-axis, y-axis, and z-axis, and the gyro will store the data of rotating it x-axis along with respect to x-axis or y-axis or z-axis, and temperature will store the temperature values. So now what I need to do, I need to print those values. So serial print in acceleration meter per second square. This is the unit of acceleration, and I am saying that in the serial monitor this message should be printed. This message should be printed. Okay, fine. And then serial print. Notice the one thing. Notice serial print in and print. What is the difference between these two? When I am writing serial print in, that means after printing this message, go to the next line or new line. Okay, but if I just write print in, that means after printing this, stay in this line. Okay, so in the next line, serial. Okay, serial dot print. I think something has happened. Sorry for that. I need to correct this. Okay, fine. Serial dot print bracket double quotation x semi x, and what will be printed here in this before after the x, the serial print acc dot acceleration dot x. That means after writing x or printing x, print the acceleration along the x-axis, and similarly print y, and after printing y, print the value of acceleration along the y-axis, and similar for the z-axis, after printing z, print the value of acceleration on the z-axis. This is the interpretation of the code. And then here comes the next part, that is serial print in rotation degree per second. That means print the this message, okay, and then go to the next line because that is in. Okay, when after coming the next line, I'm saying that serial print in the serial monitor, print this message x. Okay, and then after printing x, print serial print. That means print in the serial this means actually this means the angle of the along the x-axis. When the suppose if it is rotating along with respect to x-axis, definitely it has angular velocity, and angular velocity means by radian per second, and this is giving me the value. But I need the value into degree, so I need to convert it into degree. So that's why I am multiplying 180 into 180 divided by pi. I think you are familiar with this. If I want to convert radian into degree, I need to multiply the radian in with 180 degree and divide it by 3.14. And in the same as I have explained earlier in this section, acceleration section, and the meaning of this line, that print in the serial monitor y, and after printing y, print the value of the rotation along the y-axis, and this is because to convert the radian into degree per second, degree per second. And for the same explanation for the z-axis, and that's it. And then after the very last, I have to explain these 4 lines. Serial print, I think you've got the point what is going on here. And then serial print in temperature dot temp dot temperature, and that means I am saying that or commanding to print the temperature value in the serial monitor, and then serial print in. This line is for like giving a new what can I say, section or new blank line, huh? Oh, this is already mentioned here, that gate. And then delay for 500 seconds. Okay, and then here comes the end of the code. Let us try to simulate this. It will take time. Okay, close it because I haven't add the library. So come here and write MPU. This comes, then I have, it's okay, fine. Let's come to the code and then simulate. I think you can see that it is being updated after a certain period of time that I have mentioned here. And for the explanation, I am pausing this. You can see that, as I have said earlier, that I want to see this command. You can see this command. This is written right in here, and I want to see the acceleration along the x-axis. You can see that there is no acceleration along the x-axis, there is no acceleration on the y and y-axis, but z-axis it has some acceleration. Then comes the rotation. There is no rotation on the with respect to x, y, and z axis. That means it is not rotating. It is still but going upward. Okay, I'm saying again, like if like a helicopter. Okay, it is not going right, left, front or back. It is just going upward. This data showing me, giving me this kind of sense that my vehicle or my drone is also doing something like this. And then this is the repetition again, because I have said that they say that after 500 seconds do this again, so it is doing this again. Because if I want to update this value, what I will do, I think this is, I'm showing you again. Press in this black part, and then if you change the parameters, you will see the changes. 0, like I am also reducing this, and temperature can also be changed. And then come to the point. See, I have shown you earlier that the acceleration was along the x-axis and y-axis 0, but z-axis it was 9 point something. But now you can see that it is 11 point something, y is minus 10 point something, z is minus 2 point something. So this change has been made because I have brought changes in the drone or the machine environment. And how in this, but in this simulation I have made the change with the very previous work I have done by changing the parameters. And rotation, at first there is no rotation along the x with respect to x, y, and z axis, but now it is rotating 85.09 degree per second. And along the with respect to y axis it is rotating minus 100.05 degree per second, and with respect to z axis it is rotating in this degree. The temperature is this. And now you can change the value as well. And if I start this again, then you will see the live changes, and like this. And I'm changing the parameter again, and now you can see the z-axis. You'll just see the z-axis was minus 2 point something, that is 4.41, and the x-axis is minus 20.25, whereas it was around 180 point something. The temperature has also become changed. And this is all about today's coding and program. One thing I need to say that what this G denotes. G means 9.8, 1G means 9.8, 2G means 9.8 into 2, 1.2G means 9.8 into 1.2. Okay, I think you have got the point. This is all about today's coding and programming. If you are enthusiastic about drone and this type of projects, I think this will help me a lot. Definitely you have to have knowledge about gyroscope and accelerometer. So I think you will get the help from this video. So thanks you so much for watching my video, and keep watching. Do subscribe, share with your friend, and definitely give me suggestion what type of development I have to do in my channel. Let me know and help me to grow.